In this experiment, we observed Newton's second law of motion. Newton's second law states that the sum of all forces acting on an object, which is called the net force, divided by the mass of an object is equal to the acceleration of the object. Because the acceleration and the net force are directly proportional to each other, an object will accelerate in the same direction as the net force acting on it. To find the net force, one can find the vector sum of all forces acting on an object. For our experiment, the net force looks like this, but we'll explain that more later. We wanted to show how this law applied to a situation we've all been in, being late to a flight and having to run with our suitcase across the airport to try to make it. We started by pulling a suitcase with a known mass at an acceleration determined by the slope of its velocity graph. Our force diagram shows the friction force between the wheels and the floor, the normal force, the weight force, and the tension force, which is just the force generated by the person pulling the suitcase.
For this experiment, we will assume that the friction force is insignificant as the suitcase was rolled on a smooth surface. We will also assume that the angle between the person's arm and the suitcase is insignificant, making the tension force a horizontal vector. As you can see, the weight force and normal force will cancel each other out, leaving us with a tension force as the only force to calculate. The net force points straight to the right because that is the direction of the tension force, which represents the horizontal component, and in this case, the total net force. This is also the direction the suitcase accelerated in. Using Newton's second law, this is the horizontal component of the force we would expect for this example.
After testing the equation in this way, we decided to prove if the law held true when the net force was known. We tested this 3 times, using a force scale to determine the tension, which in this case was the net force, that we used to pull the suitcase for each trial. Our first 2 trials showed a very low % discrepancy because the experimental acceleration was close to the theoretical acceleration, which was found using the net force and mass. The third trial showed a high % discrepancy due to the difficulty of achieving a constant acceleration from an increasing velocity. Just as before, the force diagrams show a net force pointing straight to the right. Taking it one step further, the acceleration would look like this. The % discrepancy between the theoretical and experimental accelerations comes into play on the force graph. The discrepancy does not change the direction of the acceleration vector. It would just change the length, which is referred to as the magnitude. So the next time you go to the airport, maybe you can appreciate how people are able to make their heavy suitcases accelerate behind them as they rush to their flights. I know we will.